Hello students, welcome back to TutorHub, your e-classroom on YouTube. So today we'll learn about Pythagorean Theorem and angle sum of triangles. So we will use these equations and formulas to solve the missing parts, missing angles, or missing sides of a right triangle. So I'm sure you're all excited, but before we proceed, don't forget to subscribe. Click that subscribe button now, everybody. Yes, thank you for clicking the subscribe button and like this video and leave a comment so that we can interact and we can learn more together as we proceed with our videos here and in the future. Okay? So, how can you find the missing side of a right triangle? Okay, so this is a question that we will be asking today during our lecture. Of course, we can use what we call the Pythagorean Theorem. So the Pythagorean Theorem is important in calculating the missing side of a triangle. And if you recall that c squared equals a squared plus b squared, where c squared is the length of the hypotenuse and a and b are length of the sides or legs of the triangle. Okay? Now, what is the mnemonic device to easily remember the primary ratios of trigonometry? Right? Remember in our previous videos on the 6 trigonometric functions, we've discussed this. And what mnemonic device did we learn there? Yes, SOH CAH TOA. SOH CAH TOA meaning sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent side. Don't forget this mnemonic device. Now, let us try to have this particular example. So in this particular example, we have the length of the hypotenuse because it's opposite the 90-degree angle for the right triangle, and the side and the length of one leg. Okay? So how do we solve the length of this side and the angles of your right triangle? That's what we will learn today. So to know or to determine the length of the side of the right triangle and the angles, okay, we will first do Pythagorean Theorem. Okay, so in Pythagorean Theorem, we have c squared, the length of the hypotenuse, to be substituted here, and b squared, the length of one of the sides, which will be substituted here, so that we can solve for the length of side A. So substituting 23 squared from the hypotenuse and 17 squared from the length of one leg, then using your calculator, what's 23 squared? And what is 17 squared? Okay, press your calculators, everyone. Yes, very good. So 23 squared is 529. 17 squared is 289. Okay, and we need to isolate our a squared here because that's what we will be looking for. So what we do is we transpose 289 to the other side, making it 529 to 289, right? Remember, when we transpose a number to another side, the original sign of that number becomes the opposite. So if it's positive on its original side, it becomes negative on the other side where it is transferred. And here, a squared is left. So simplifying further, what's 529 minus 289? Very good. That's 240. And because we want to get a, we need to get the square root of both sides. And getting the square root of 240, get your calculators. What would that be? Very good. That's 15.49. Therefore, the length of the side of leg A is 15.49. So here we first were able to determine the length of one leg given the length of the other two legs of the triangle or the other two sides of the triangle using Pythagorean Theorem. Okay? Any questions, everyone? If you have questions, write it on the comment section below. And don't forget to like and share this video and subscribe to the channel. Now that we have the length of the three sides, we can determine the angles, right? The measure of the angles of the triangle. Remember, we have SOH CAH TOA. For SOH CAH TOA, we can use the opposite, hypotenuse, and adjacent sides of the triangle to determine the measure of the angles for that particular triangle. So if we have sine A, right? If we use and solve this, if you solve this angle first, angle A, we can use SOH, which is opposite over hypotenuse. So what's the length of the opposite side of this angle? That's 15.49, and the length of the hypotenuse is 23. Okay, so if we substitute that, we have 15.49 divided by 23. Very good. Then we need to calculate A, right? So in your calculators, there's something called shift sign, okay, which will give you the sign -1 notation on your calculators, and you operate that with the values for the opposite over the hypotenuse of opposite side over the hypotenuse of your right triangle. So A would be sine -1 of 15.41 over 23. Make sure you're able to click that in your calculators properly. Okay, were you able to get it? What did you get using your calculators? Very good. So angle A would be 42.34 degrees. Okay, don't forget the degrees here. That's a unit of angles. Okay. All right, so that's the length of angle A, 42.34 degrees. I hope everybody got the correct answer. Okay. Now that we got the length of the measure of angle A, let us try to determine and check whether we get the same answer if we use cosine, right? Cosine A is adjacent over hypotenuse. So this is the adjacent side of the angle, and this is still the hypotenuse, right? The hypotenuse doesn't change. Okay. So the adjacent side is 17, hypotenuse is 23, so that's substituted here in this equation. We do the same thing. We click shift cosine in our calculators, or however that is for your specific calculator. So be familiar with the operation of your own calculator so that you'll be able to solve trigonometric problems properly. So clicking your calculator shift cosine will give you cosine -117 over 23, and the angle A would still be 42.34 degrees. So that's the same as what we calculated a while ago. So whether you use SOH, CAH, or TOA, you are expected to get the same measure for that particular angle. Okay? If you did not get the same measure, then you might need to review your answer so that you'll be able to refine your calculations. Did you get that, class? Very good. Okay. Now, let's use tangent. Okay. Tangent is opposite over adjacent. So this is angle A. Opposite side is 15.49. Adjacent side is 17. So substituting that, 15.49 over 17. Then same, click shift tan. So you get tangent -1 of 15.49 over 17. You should still get 42.34 degrees. So nothing should change whether you use SOH, CAH, or TOA. Is that clear? So whether you use SOH, CAH, TOA, for as long as you referred to the proper angle correctly and you use the opposite, adjacent, and hypotenuse properly in the equations, then you'll get the same answer. Okay? I hope that's clear, everyone. So Angle A is 42.34 degrees. What about angle B? Okay, there's something called triangle sum theorem. And the triangle sum theorem states that the measure of angle A plus angle B and angle C of a triangle is equal to 180 degrees. Now, we have the length of one of two angles on this right triangle. We solve 42.34 degrees together, and we know that this one is a right angle, right, at 90 degrees. Therefore, we can solve the length of angle B using the triangle sum theorem. Okay? So, substituting the angles further, 42.34 is substituted for A, and the right angle is substituted for C. Then, transposing all the values to the other side, we isolate B here on the left side. So, 180 minus 42.34 minus 90 degrees. That would be 47.66 degrees. So therefore, the length of, or the measure of angle B should be 47.66 degrees. Okay? Is that clear? So that's very easy, very methodic, and a step-by-step way of solving the length of the side using Pythagorean Theorem, and then using SOH CAH TOA to solve the measure of one angle, then using the triangle sum theorem to measure the length, or to determine the measure or of the other angle of the triangle. Okay, so I hope that's clear, everyone. So this is now our right triangle. Okay, let's check whether 47.66 is really correct, right? Is really the correct measure of this angle using SOH CAH TOA. So let's use SOH, or sine B is equal to opposite over hypotenuse. So with respect to angle B, the opposite side is 17 and hypotenuse is always 23 for this particular triangle. So you have sine B equals 17 over 23. Then shift sign 17 over 23, we get 47.66 degrees, which is the one that we got using the angle sum theorem. Let's check whether we get the same answer using cosine and tangent. Okay, use your calculators and check whether you get the same answers for SOH CAH TOA. Okay, so we solve for SOH. It coincides, or it's equal to what we calculated in using the angle sum theorem, and the SOH, or sine, equals opposite over hypotenuse. Try to check whether it's the same for cosine and tangent. Okay, and you should get the same answer. Okay, now let's try another right triangle. So in this case, we have the length of the hypotenuse, two angles, 58 degrees, and the right triangle, which is 90 degrees, but we don't know the length of the two legs and the angle. So it's another scenario. What if you have one side, the length of one side, and two angles given to you? So how do you solve that? Okay, so to solve that, we first solve for the length, or the measure of the third angle using the triangle sum theorem. So using the triangle sum theorem, that's angle A, which is 58 degrees here. Angle B is unknown. This is what we will solve. Okay, and angle C is simply 90 degrees right here. Right, so substituting the values, that would be 58 plus angle B plus 90 degrees equals 180. Then we need to isolate angle B so that we can solve its value. So it's 180 minus 58 minus 90 degrees. That would be 32. Okay, so 180 minus 58 minus 90 is 32 degrees. Okay, so that easy, we're able to solve the measure of the unknown angle. Okay, so at this point, we do not know the length of the two legs of the triangle. So what do you think is the best method to solve the two legs, the length of the two legs? Very good. So we can use SOH CAH TOA, right? Because in SOH CAH TOA, we have the angles and the length of the hypotenuse, so we can get the length of the opposite side, right? So if we use sine 58 because it is given, so sine 58 and we do not know the length of the opposite side, okay, so we represent that with the small letter a over hypotenuse 27, that's given. So substituting what we are given in the equation, right, sine 58 angle a, then hypotenuse is 27, we don't know side a, which is opposite of angle a, then we can transpose 27 to the other side to multiply 27 with sine 58, and we will be able to solve side A this time. Use your calculators, everyone. What's 27 times sine 58 degrees? Very good. So A, length of side A is 22.90. Okay? So I hope everybody got that correctly. Okay, so that's 22.90. Very good. Now, we need to solve and check whether we get the same answer using tangent. Okay, so tangent A, still A is 58 degrees. The opposite side is unknown, and the adjacent side is okay, we will solve for the adjacent side this time. Okay, so tan 58 equals A over B. Okay, so B sine 58 equals A. So we are solving for, this is A and this is B. So we do not know A and B if we use tangent A when solving this problem. Okay, so let's say we have B sine 58 degrees equals A. So since we know that A is 22.90 degrees already, then we check our answer using cosine A, right? If we use tangent A to solve for B, right, at the start, and we do not know both A and B, we will not be able to solve the problem correctly. Okay, so that's the purpose of this slide. We wanted to show you that if you use the wrong trigonometric ratio or trigonometric function to solve for the length of the sides of the triangle, and if at the start you do not know both sides, the length of both sides, then you might not be able to solve the problem correctly. Okay, so it's very important that you know which trigonometric function or trigonometric ratio should be used for a particular problem. So in this case, if at the start we don't know the length of sides A and B, we cannot use the tangent function. Okay, is that clear? Now, because we already used we already solved 22.9 as the length of side A in our previous calculation, let us try to solve for side B. Okay, cosine A equals adjacent, this is the adjacent side B, which is unknown, and hypotenuse, which is 27. And our angle A is 58. Okay, so substituting cosine 58 equals B over 27. Solving for B, that's 27. Transposing to the other side, that's 27 cosine 58 is equal to B. Use your calculators, everyone. What's 27 times cosine 58? Very good. That's 14.31. Okay. So the length of side B is 14.31. Okay. So that is, so at this point, we're able to solve the three angles. We already know the three angles and the three sides of the triangle. So that's how easy it is, right? So again, we use the Pythagorean theorem to determine the length of the side of the unknown side of a triangle. If you're given two sides, the two lengths, the length of the two sides of the triangle, then we use the angle sum theorem to determine the length of the third angle, the measure of the third angle if you have the two angles given to you. And then we can use the SOH CAH TOA to determine either the angle or the side. But make sure you use the correct trigonometric ratio depending on what values are given to you. Okay, so I hope that is clear for you. And yeah, we have this. If you use tangent, the tangent function, opposite over adjacent, that would be tangent 58, opposite over adjacent. We don't know the adjacent side, right? So that would be an unknown. So we cannot solve this. We may not be able to solve this, but yeah, we can solve this by dividing both sides by tangent 58. So if we use tangent, we don't know the length of side B. So if we use tangent, we have the length of the opposite side. Check. The adjacent side is B, which is unknown. We know side A. So we have two knowns and we only have one unknown. So in this case, tangent A can be used to determine the length of side B. Okay? So if you have tangent 58 equals 22.90, which is what we solved a while ago, and B. So we transpose B to the other side, and then we get B tangent 58 is equal to 22.90. So to isolate B, to solve for B, we divide both sides by tangent 58. So this cancels. And what is 22.90 divided by tangent 58? Use your calculators, everyone. What is the answer for that? Very good. That's still 14.31. So whether we use tangent or cosine a while ago, we were still able to solve for the length of side B. Okay? What if we use Pythagorean theorem? Okay, can we solve the length of side B? Yes, right? Because we have the length of the hypotenuse and the length of side A, so we can definitely solve for side B. So substituting the value, C is 27, A is 22.9, square 27, square 22.9, what do you get? Use your calculators, everyone. Yes, very good. You get 729 and 524.41 respectively. Transpose this to the other side. This becomes 729 minus 524.41 equals B squared. Simplifying this further, we get 204.59 for B squared, but we want to get the value of B. So we get the square root of both sides to get the value of B, and that is 14.30. Okay, so we get the same answer for all these methods. So you have many ways to solve the unknown angle or unknown side of a right triangle. So again, that's Pythagorean theorem, the angle sum of right triangles, and SOH CAH TOA. So all these techniques should be used by you so that you can solve the angles or sides of your right triangles. Thank you everyone for listening and for learning with me. Don't forget to click subscribe to this channel, like the video, and leave a comment. Thank you so much and have a great day ahead. Happy learning, everyone!